Okay, just want to give you a few things to think about for factoring as you work on this packet over the course of the next week. First thing you want to do is make sure you look for any greatest common factors and look to remove those from the expression. After you do that, some other structures may reveal themselves. So you may not see them right away, like a difference of squares or perfect squares, but look for those, and especially after you do a GCF, because there may be more methods to use. And if you're unsure, grouping or the box method techniques are helpful if you still need some practice kind of seeing why things are the way they are. So I just want to do a couple of these really quick. So if we look at, number one is simply a perfect square. And what I mean by that is 5 squared is 25, and 5 plus 5 is 10. So I can see a pattern on this when we're looking to separate this into two linear factors. So x times x is x squared, 5 times 5 is 25, and then 5x and 5x give us the 10x. So this can be written as x plus 5 squared. So that's why it's called a perfect square. Number two is a difference, so subtraction of two perfect squares. 36 is 6 squared, and x squared is x squared. So when it's a difference of squares, we look at those as very similar, just different operations in between the two. Okay, because we don't have that middle term, that linear term like we do in this first one, because I'll get negative 6x and a positive 6x, and those cancel out when it's a difference. So a negative times a positive gives us this negative x squared, and also eliminates the middle term. I also wanted to look at number 6. 6 is always thrown students off, but this factor of x minus 6 is a GCF. And so what I mean by that is, if it was written like this, 10a minus 3xa, you can see that a is a factor of both terms. But what throws students off is that the factor is itself a linear binomial, but you'll still be able to factor it out, just much like we would if it was just in single a. So I can factor out x minus 6, leaving 10 minus 3x. And so it's like this whole term is the GCF being distributed. Okay, and so that happens in number 19. So if you can see 19, same thing, I can factor out the x plus 3, leaving x squared minus 9. And so after factoring out the GCF, I have another difference of squares. So I can keep going on this one. X plus 3, and then x plus 3, x minus 3. So now it's factored completely. So always look for the GCF first, and then look for some structures. Even if it's fourth power, that's just m squared. So this would be m squared minus 4, m squared plus 4. Okay, so 4 and 4 gives us the 16. The fact that one's positive and negative cancels each other out. But then this one, I also have a difference of 2 squares. So that would be m minus 2, m plus 2, and then the m squared plus 4. All right, I'm going to leave it at that and let you work on the rest of these.